Let's go ahead and get into chapter 7. And this week we'll go over chapters 8 and 7, and we'll go over these. I appreciate you fitting in all of these exercises as well as all this reading. Just to review, the general goal is to get 4 applications written, which means that you can take a selection between the 2 chapters. So for example, maybe for chapter 7, you grab 2 exercises, and maybe for chapter 8, you grab another 2, or maybe you do 3 and 1. It'd be good to spread yourself out because, of course, there are different exercises that are going on here. Half the time I debate whether we should do an all-video textbook and we should just have a bunch of source code and I would walk through it. We're probably 50% of the way to doing that. Currently, I think this textbook is gaining so much acceptance that I think for example, I was looking at a Python course on Coursera by the University of Michigan, and they were assigning this very textbook to their students preparing to go into data science in the School of Information. So your colleagues and your peers at University of Michigan are very committed to this textbook. So I was amazed to see them using the turtle graphics and all the same source code that we do here at Coastline. Nice to have company. I remember specifically using this textbook when I was a graduate student, and that was 2003 when I took a course where thinking like a computer scientist was delivered using Java. And I'm sorry if I said that last time. I have a tendency to repeat stories. But I like to give you guys a little bit of context. So let's go through a few Python applications. Turtle is a specific graphic application for Python. And you can see this one is chapter 7. This number 5 example is pretty substantial. Where, of course, we're grabbing the Turtle API. We're grabbing the Turtle object so we can program against it. Then we're defining a definition or a function right here called drawBar. And you can tell that this is a function. All you need to do to define a function in Python is to place the semicolon or the colon and then to indent throughout your code there. And most editors will give you an automatic indent until you press delete, and it will move forward. And let's just kind of back up a few lines. And then once drawBar is defined, then you have the liberty to use drawBar down right here. Now, last time we were talking about the repetitious nature of for loops. And for me, for loops are like going to work with being a carpenter and having a electric screwdriver. It's just something power driver. It's something that you use every day, and a lot of your work is done because of the automation offered through the for loop. So here, we're kind of using the for loop as a place to tee off. And we're sort of saying, look, the big move is going to happen once we run the for loop. And so what we have is we have items that we create automatically, and usually XS represents a limit or a certain number of values that we're going to use. And so what it implies is that we're going to iterate or move all the way through 48, 50, 200, and we're of course going to paint those values, but we need to submit one of the values inside of XS. So what's cool about this, and this is what you would call an array, and frequently we want to grab an array of data, whatever format. It could be coming from across the net. In this case, this is kind of a discrete set where we're defining the possible values. And so the program knows ahead of time just how long the array XS is. The length of XS or any array is important because what a for loop really needs is a limit. A for loop needs an integer number of times for it to run. So for example, it can take the limit of XS, which I believe is 1, 2, 3, 4, 5, 6, 7. And then, so instead of, what we could do is, if you were to go ahead and print the length of SS, that would allow us to, let's see if that works right here. I don't mean to throw a wrench into things spontaneously. You can see that the length is right there and it's printing to the Python console. And then that happens independently from the windowing that we create via the window that we create, this turtle screen. But this is the internal console. And so we're going to say, well, go ahead and print the length of XS. So XS has a couple of attributes. One is it has 7 pieces of data, and then these are the members of that array. So an array is kind of a tool. It's a multifaceted tool. Also, as you iterate the array, you're giving up the position. So we could, and you can tell I do a lot of print statements here. And we just say current value of A is, and then we can go ahead and run that. Now, what I'm hoping to do is to expose the current value of the for loop as it executes. And that's what we would call the index value. And so as it loops through the window, it's kind of giving up the next value that it's consuming. And that's kind of nice as you have the graphical, the SVG output here, the graphical browser output, and then you have the, the iterative value as we loop through that array. So nice stuff, beautiful. Now I can simplify this, but I like the output, so I'm going to keep that there. But I use that because drawbar is going to begin right here, and you have these pretty and when we use that when we use the incoming value drawing for height, and what I do is I separate the value, the variable right here from my template. This is called a template, where I use the console to output, and I submit. So for drawing for height 48. Now that helps me illustrate what's happening, because height is what we call an argument, and this is what's called a method argument or a method signature, where the signature has 2 values that it's submitting. And you can see that it's prepared. Drawbar is prepared to accept 2 parameters, height and t. And let me clarify the significance of t. Drawbar tests. And let's go ahead and output. And then we can also say, and let's go ahead and inspect tests. And we go ahead and run that. And then for test turtle, and that is the instance of turtle that it is building at that time. And so let me go back, and that is going to be the test. And so what we do is the turtle, her name is Tess. And if we wanted to, we could just call it Tess right here. But if we did, we would need to refer to it as Tess right here. That's fine. So we're just going to use T as and I appreciate that because it's nice and efficient. And then we'll go ahead and leverage and use that. Drawbar is using 2 pieces of information. It's using the test, which is a turtle object, and it's using the index value, or the current value of XS. So that's a lot. I sense that for loops, I think for students are, the hardest thing to learn. I think they're very mature programmers depend upon many for loops, and they use for loops. And as you get into more algorithm design, your for loop becomes indispensable. So I sense that if you learn the for loop by the end of this class, you're in a very good place. And I think probably if you can learn it by the end of this week and you can memorize the for loop, computer science is going to be I'm not going to say it's going to be easy, but it's going to be a whole heck of a lot easier. But we always use, this is our power tool, the for loop. So before that, though, Tess is instanced with an instance of turtle. And, turtle, the soul of turtle is that you begin with a declination or a direction. And firstly, you turn the pointer, this little guy, in the direction that you want it to go, and then you move forward a certain length. In this case, we use the height length, so that gives us a kind of a histogram. So you're always creating a declination or a vector, a direction, and then you're specifying to move, a certain number of units. And so this is going to be a angle, a radian, and then this is going to be a pixel or a unit. So for here, we're kind of configuring a graphic. And why don't we, just challenge it a little bit with a new array member, and we'll have it draw a 300. That's great. And boy, that's efficient. It's just whipping right through. Now, let's just be honest. The turtle graphic is important when we're drawing pictures, but imagine how efficient Python is when doing infographics or graphs. For those of you interested in data science, I think Python has had to go head to head with the classical language of R. R is the Mercedes-Benz of data science. And before there was before there was data science as we currently know it, there was R. And really the worlds of Python were for the big search engine companies and the big text mining companies to use to kind of acquire HTML from the net. It would scan web pages, and Python was really optimized for page scraping. And then doing analytics on HTML or scraped HTML. And so what's happened over time is the various text mining organizations, Google most significantly, would be fashioning new machine learning and new data science libraries inside of Python. And so very gradually, a lot of the quality that was inside of the R language, when R is kind of the Mercedes-Benz, as I said, of data science, a lot of the prior work is done on R. A lot of the high caliber stuff from R was ported over to Python. And so now as you go and you visit with new data scientists, and you really see that Python has become the dominant, the most used language for data science. But that doesn't change the fact that there are numerous PhDs who are statisticians and real scientists who learned statistical learning, really advanced science, whatever that is, via R. So I think we like to respect both. Python obviously has won a lot of battles versus R. We're not taking an R class. It's very rare for folks to use R in computer science. It's great for folks who are in economics and other statistical discipline to use it. It's a huge tool. But here, the turtle is kind of classic Python. But you can just imagine how nicely it draws on web pages. It's kind of an example of how the battle for scalable vector graphics, or SVG, has kind of been won to some extent by Python. So this is the turtle, and this is how we configure the turtle. And then we can configure the window, and then we will go ahead and set world coordinates for that window based on the dimensions of the screen that it's using, the block that it's using. And then from there, it's going to iterate a series of Pythons. Or of turtles, I'm sorry. So that's fun. I appreciate that. I don't want to overtalk and misuse your patience. Let me see if there's anything else. I think though that this kind of use here, I'm going down to 11 real quick. Something to keep your eye on this week is whenever we create a function, we need to have a method signature. So we're going to ingest three pieces of data. And as we ingest, the reality is A, B, and C can be defined inside of this method signature, but we can't use A, B, and C out here. So if I were to run if I were to ask for A, it's going to fail because A, you're like, well, wait a sec. I defined A in the method signature, but it's not going to work if I put it down here. There's a limitation of the scope wherein A can be used. A needs to take place within the function. And let's remember to, it'll read the function so long as it's indented. And you can see that this is a method, a parameter ingest, that the function is kind of taking in A, B, and C. But A, B, and C are defined the moment that the function is interpreted and used. Is right angled is really just feeding variables into is right-handed. And then those parameters get established by the function. So when this is right angled, when it is interpreted, when we first turn on the program and we press run, the internal memory structure of the browser sees is right angled, and it says, okay, whenever right angled gets used, we are going to consume these variables. And that is a really cool lesson for programmers to learn at this stage of the game. So you guys are using, for loops in tandem with functions, and that's technically what a math function has to do. If we provide a set of arguments that are formatted consistently, we should receive consistently accurate results. Now, in this case, we have floating point, decimalized numbers, probably within some continuous set of numbers where there's not really a limit to the precision of these numbers. And we're feeding this in, and right angled can handle precisioned numbers. And it can do, it will do an absolute value. And then if the absolute value of that is, below a threshold, then the right angle is, is true or false. I don't want to get into the details of the rules here. I'm more interested in the structure of this thing. So good. Moving on, not to make you listen to too much. All right. So for chapter 8, something similar where we're defining a function, and we're using it here. What I find interesting is we're using the while, and it's nice to contrast for and while, because the while is a fundamental part of any for loop. So let me just go up real quick. At certain points in your career, you're going to try to use a for loop. So right here, that's a for loop. We like when things use a for loop and can work with a for loop. But a for loop works in this moment. So for example, the for loop is kind of like an if statement. It works once, and it'll work until it's finished, and then we move on. We move below it. What's fascinating about a while is that a while we don't really turn off the while. The while can execute throughout the duration of the program. So better, it has a life cycle that begins right here and it ends right there. But while this code is executing, the while loop will work. But technically, if we had several variables, let's say we had a variable up here, and what if we wanted to evaluate x? We could do so throughout the runtime of the program. And I'm just doing a quick example. Let me do a quick, I don't want to change it too much, but while has the ability to listen for changes in a variable, and if that variable changes the value, and it can be evaluated, and when the value of a variable changes, we can say, well, if it changes in a certain way, then go ahead and throw or execute this code. So while is what I would call a global listener. It's listening to the changes of variables as they change across the scope of a program. Now, in this case, the scope of better is limited to the function. So it's while the function is running, better gets looked at. And so that's an interesting contrast to its cousin, the for loop. The for loop is kind of the more the better looking, more athletic cousin who gets more dates. People call upon the for loop daily, and then the while, it gets reserved. It gets used very seldom. I think I've used the while maybe twice in the last 4 years, maybe more, probably not many more. And I use it during what are called recursive algorithms, which are algorithms that need a for loop but can't use a for loop because of their complexity. And so we actually ask for while to stand in for the for in very specialized circumstances. But typically while gets used when we need to listen for changes in a variable during the program. So if one of these variables changes, i.e. if better changes while this program is running, we need to assess the updated value of that variable. I hope that, and let's just run that real quick. Good. So this is a good one. This is inside of 8, and it's example 3. And I'll go through this one, then I'll let you go. But I want to print the result of the is prime. And so I'm going to feed in these integer values to is prime. And it is going to return a true or a false. And so if we take a look at a range of variables, which is between the range of 2 always, and then whatever number we're feeding, and if the remainder of this thing is 0, i.e. if it has a kind of, it's an even number, it always divides nicely, and the modulus of the remainder of multiplication or division is 0. And this mod is kind of a classic computer science. We don't use it a lot in industry, but it's kind of nice to know it's there. The modulus helps us to define even and odd numbers. And believe me, if someone's worked on a program where they define even and odd numbers, more power to you. So we're going to ingest that variable, and then we're going to make a range out of it. And so what's interesting is you're like, well, range is a little bit like the length of that we were discussing here in chapter 7. The range of something implies that there's a length or there's a certain discrete number set or a number set with predefined numbers that operates between this start and this end. And so thus we create an implicit limit that limits the number of times that for can run. And so we're going to evaluate these 4 numbers for their evenness and give it a false or a true. All right. So I think that's probably good. That'll probably be enough for you to get started on things. And just keep in mind the definite, how Turtle works. And we're keeping you busy with these right here. So look, good work. Keep up the good work, and let me know what I can do. Thanks.